Good morning. I'm Bhuvaneswari, doing my research under the guidance of Dr. Varalakshmi. I'm here to present you a comprehensive overview of LLM-based approaches for machine translation. I would like to have a short introduction about machine translation. Machine translation is a technique that uses algorithms to translate text from one language to another language automatically without human intervention. And it is one of the most common NLP tasks that has gained popularity because of its exponential growth of text and speech data. And it produces automatic, fast, and error-free translations. With the traditional human translation, it is very much labor-intensive task where it is time-consuming. But the machine translation can instantly translate vast amount of text with minimal human involvement in it. The major applications of machine translation includes text to text, text to speech, speech to text, speech to speech, and then image to text. And the application domains include government sectors, software and technology, military and defense sectors, healthcare sectors, finance and legal sectors, e-commerce, e-discovery, etc. And then statistical machine translation. Statistical machine translation, it employs syntax-based models in translating source sentences into target sentences. So this relies on statistical approaches with large parallel corpora of text. The major advantages of SMT include where the SMT ensures every word in the source sentence is translated into a semantically related target phrase. So here, all the translations are distinctly memorized. That includes rare words, and every word is treated as a discrete symbol. So apart from the advantages, the major challenges seen in SMT includes where it struggles to produce a fluent natural translation, and it is difficult to handle long range dependencies. And the development of translation rules, dictionaries, and parallel corpora for SMT systems requires a significant amount of human involvement in it. Evolving from the SMT, NMT systems employ sequence-to-sequence model based on the encoder-decoder architecture, which uses LSTM, GRU, and transformers. Here, the encoder neural network converts source sentence into a vector representation that is in the form of numericals, and this encoded vector is fed into the decoder that applies teacher forcing technique to use the ground truth instead of the previously decoded words. And this generates one word at a time during the target translation. The major advantages of NMT include where it learns from data directly to generate more accurate and precise translations with improved ability to manage long distance dependencies. It captures the contextual information and it adapts to new language pairs or domains when it has been fine-tuned. And when compared to SMT, the memory consumption of NMT model is significantly less and works much faster than SMT, which yields better results for high resource language pairs. The limitations found in NMT include where it struggles with rare words, out of vocabulary terms, and then when it is trained with low resource language pairs and out of domain data. As well, it is computationally expensive to train large data sets when deployed large models. And from the NMT, large language models, as the name implies, these are pre-trained transformer models where it has been already trained with huge volumes of data for various tasks like text summarization, translation, question answering, and sentiment analysis. And these models are further fine-tuned or prompt-tuned with smaller set of specific data sets for a particular domain to meet the tailored requirements of the users. And the availability of voluminous data and innovative architectural designs and the technological advancements enrich the further breakthroughs in generative models. The pre-trained LLMs, as well, they capture a wide range of knowledge. They identify the statistical patterns, relationships in the training data, and they improve the language comprehension to produce a natural sounding human-like text. And then the limitations, sorry. The advantages in LLMs include rapid advancement of LLMs has led to a paradigm shift in machine translation, giving a good contextual understanding, precise results, and fluency. And LLMs, they reduce computational cost to a greater extent and resource requirements also, which is better than the SMT and NMT models. It is then integrated with other NLP applications for summarization, question answering, and exploring rare and unseen language pairs, which makes a wider room for the research community. The gap analysis of the existing review on LLM-based machine translation. Here, the existing literature focuses only on SMT and NMT translation that investigate several approaches for enhancing the translation quality, but then it fails to analyze the numerous works that are being published on employing LLMs for machine translation. The main objectives of this paper here, we present a detailed review of the latest approaches in LLM-based translation, and this serves as a pivotal resource, the main resource for researchers who wants to deepen their understanding and knowledge in this particular domain. And this exhaustive survey also spearheads diverse LLM research works which gear towards addressing the challenges of LLM that include hallucination, translation bias, etc. The major sections of this paper include pioneering research on LLM-based machine translation, LLM prompting, LLM fine-tuning, LLMs for low-resource languages, and quality estimation with LLM. The papers that have been reviewed include for the period of 2017 to 2024, reviewed almost with 80 scholarly articles. So this is the papers that we have reviewed. Most of the recent papers have been reviewed here in 2023 and 2024. These are the research recent papers. The pioneering research on LLM-based MT have been taken with from the year 2019 to 21. The rest of all the papers have been reviewed with the recent ones alone. Pioneering research on LLM-based machine translation in sequence-to-sequence models. Here, it uses the incremental decoding technique to enable the rapid inference for non-recurrent models for increasing the prediction rates. In multilingual NNT model, here it uses the transfer learning technique to resolve the data scarcity issues, specifically for low resource languages. Here, in regressive models, the editor transformer is trained through reinforcement learning for source token that allows source token repositioning and incorporates soft lexical constraints, etc. Then Lewisham transformer, here it applies the iterative refinement and sequence level distillation to automatic post-editing tasks for high quality translations. In retrieval-augmented models, here it tries to identify the similar translations and then incorporate them into the training data. So it uses the fuzzy matching techniques to identify those similar translations, and then it is being compared with the baseline model. in the retrieve re-rank framework, so it tries to retrieve the relevant outputs from each output. Then it tries to modify the candidate individually and then re-ranks the edited candidates. So here this tries to give the best translation output based on the post-generation ranking. So both these models were able to improve the translation efficiently. Then with the multilingual LLMs, the EMBARK model has been pre-trained extensively with monolingual corpora for various languages, and it uses word span masking to enhance the translation accuracy. In the next paper, Team et al. 2022, here it has used this sparsely gated mixture for expert conditional models for creating low resource language datasets using the innovative data mining tools. With LLM prompting technique, which is the most used technique in the current era, I've listed few of the papers that has been discussed in the review paper. Most of the models that has been trained for LLM prompting as no language left behind, Llama models, ChatGPT, Google, and then DeepL and Bloom. And these are the data sets that have been used, mostly Opus, Flows data set. And the language pairs have been listed here. And few of the language pairs include the Indian language pairs, Hindi to Malayalam, Marathi, Gujarati, Telugu, and other English languages also, English to other languages. So they have worked with papers with cultural awareness, and then worked with related languages also, gender specific machine translation, and how these translations have been designed for ChatGPT. So when looking into the prompt methods, mostly they have used zero shot prompts, two shot prompts, few short prompts, and in context examples with different examples like a 5 in context example, 16, 32, and few short prompts they have tried with different numbers, 0, 1, 5, where with different numbers, where they are able to achieve a better translation accuracy. And then with LLM tuning, here these are the few listed papers in LLM tuning, where here the major models that have been trained is Llama 13B, NLLB 3.3B, GPT 3.5 Turbo, Mistral, Llama, Llama 2, Llama IT, and then Llama with different parameters like 7 billion, 13 billion, and then Blue. So these are the common models that have been used for training. And the common data sets they have used is FLORS, Opus. Mostly the data sets contain these. And when looking into the methods that they have used for fine-tuning the models, they have used zero shot and one shot prompts, then fine-tuned it. So fine-tuning with contrast reference optimization was used in the first paper that has been listed. And then in the third paper, they have used fine-tuning with LoRa. And then along with this zero shot and dictionary based prompt, and then the tuning with full parameter, tuning with low rank matrices, tuning with embedded fixed. So different types of parameters have been tuning with parameters with full parameters have been used. LLMs for low resource languages here, specifically where it has been resource constrained. Here, the models that have been used include bilingual, multilingual models, no language left behind, GPT 3.5, and then Bloom's Adapt multilingual LLM, and then Llama. So with the data sets, it includes Opus, FLORS data set, and then Bharat Parallel Corpus, specifically for Indian languages. So the language pairs, if we can see, they have taken only the resource constrained language pairs of English to the low resource languages and low resource to English. So here also the methods that they have used include prompt-driven metagraph prompter along with in-context learning, then few short prompts with along with fine-tuning, and then here they have used fine-tuned LLM for the low resource languages. Next, with the quality estimation with LLM here, the models that have been used for quality estimation, Robata, GPT-3, 2, Palm, and Llama models. And these are the languages that they have been listed. Here, also they have used fine-tuning on Robata models, and then LoRa tuning, in-context learning, few shot with demonstration, and then single reference and diversified reference, and auto MQM prompting with in-context learning. So here the quality estimation with LLM also uses the fine-tuning and few short prompts for better translation accuracy. So looking into the recent papers that listed in the review, the findings show that the existing literature are predominantly addresses the SMT and NT approaches, and they pay no attention to the LLM-based machine translation works. But our study here encapsulates the recent contributions related to LLM prompting, fine-tuning, retrieval-augmented generation, and various various variants of transformer for faster translation. And our paper suggests that LLM can be trained on data for multiple languages simultaneously without having to build a separate model for each language pair, where they also demonstrate good enhanced translation results for open vocabulary translation, which can handle neologisms and rare and unseen words. So here, LLM has stronger modeling abilities for enhanced fluency, which are fluent and natural sounding, better outputs than the statistical approaches. The limitations or the challenges LLMs face include first is the lack of explicit word alignments between languages that may impact its accuracy. And the next major challenge would be where it generates factually inconsistent translations, which are prone to hallucinating facts, which is discordant with the input. It would be a major concern when the stakeholders demand precise translations. Then the computational requirements is also huge when it comes to LLMs. This may restrict the scalability for production of machine translation deployments. And then LLMs require extensive multilingual training data sets, so which is not actually available for low resource language pairs, and this makes them leave data hungry and limiting their potential. The future directions we would like to address is the translation of real-time conversation that supports seamless interaction, the real-time translation of social media posts in multiple languages so that the people around the world can understand it, and then multiple generation of subtitles, captions, dubbed audio for videos without trading of the original emotions that is shown in the video. And then translation of ancient literary works and domain-specific documents is in much need with good accuracy. And then the improved translation of sign language and spoken languages along with the multilingual chatbots. So here we'd like to conclude that this review attempts to provide a detailed and a comprehensive analysis of the existing literature on employing LLMs for machine translation. To the best of our knowledge, to till date, our LLM-based translation works have not been reviewed in the literature. So our study highlights the most significant contributions in LLM prompting and fine-tuning, which is regarded the most powerful techniques for enhancing the performance. So it also covers the major works related to LLMs, including retrieval-augmented generation, improved transformer variants, and multilingual LLMs. So this produces a high-quality translation output. Thank you.